Hey everyone, and welcome. Today, we're diving into a really interesting new toolkit for anyone out there building AI applications. It's called Rig, and it's all about bringing some much-needed order to the often chaotic world of AI development. So if you've ever tried to build an app on top of a large language model, you know it can get, well, complicated, fast. It often feels like you're trying to piece together a dozen different systems with duct tape, just hoping it all holds together. And that complexity, it can be a huge roadblock. I mean, think about it. You're juggling all these different APIs for every model. You're trying to figure out how to handle streaming data in real time. You're managing embeddings and vector stores for retrieval. And on top of all that, you're writing just tons and tons of boilerplate code. It's a lot of repetitive and, honestly, pretty frustrating work.
Well, that's exactly the problem Rig is designed to solve. It's a toolkit that steps into this mess and helps developers build modular, scalable LLM applications. And it does it all within the Rust ecosystem.
So, what is it exactly? Honestly, you can think of Rig as your Swiss Army knife for putting AI into Rust applications. Its whole job is to abstract away all that complexity we were just talking about, giving you one clean, consistent way to work no matter which AI provider you're hooked up to. All right, so what does Rig actually give you? Let's pop the hood and take a look at what makes this thing so useful. First up, integrations. This is a big one. Rig supports over 20 different model providers. We're talking OpenAI, Google, you name it, all of them accessible through one single unified interface. And that means you can finally stop learning a new API every time you want to try out a new model. And it's not just about the models. Rig also comes with out-of-the-box support for more than 10 different vector stores. Now, this is a huge deal for anyone building those RAG applications, retrieval augmented generation, where you need to connect your own data to an LLM. This just makes that whole process way, way simpler. And this isn't just some hobby project, okay? It's already being used in some seriously demanding real-world apps. For example, St. Jude is using it to power a chatbot that helps researchers sift through complex genomic data. Coral Protocol has it as a core part of their Rust SDK. And you've got companies like Nethermind and Carenify using it for some really advanced AI engines and search experiences. And this code snippet right here, this really shows you what Rig is all about. Look how clean that is. In just a few lines, you can set up a client, create an agent, give it a personality, and get a response. This is the kind of minimal, clean code that developers dream of. Okay, but let's hit pause for a quick reality check. The market for these kinds of tools is, well, it's incredibly crowded. So we have to ask the big question. Is Rig just another framework in a sea of frameworks? And that's a totally fair criticism. One reviewer put it pretty bluntly, saying they just don't see any extremely unique features that make it a must-have. And on the surface, they have a point. Supporting a bunch of models and vector stores, other tools do that too. I mean, just look at the competition. The market is absolutely saturated right now. You have the giants like LangChain and Llama Index, you've got Microsoft's semantic kernel, and the list just keeps growing every single day. They're all fighting to be the main way you build LLM apps. So that brings us right back to the central question. If the features aren't totally unique on their own, what is Rig's secret weapon? What makes it different? And the answer, the whole game changer, comes down to just one word: Rust. Rig is built from the ground up in Rust. And you know what? That changes absolutely everything. So why is Rust such a big deal here? Well, Rust is a language that's built for three things: performance, efficiency, and safety. That makes Rig a perfect fit for things like high-speed, performance-critical apps. Think real-time systems where every millisecond counts. It's so efficient it can run on edge devices, and get this, it has full WebAssembly compatibility. That means you can take the same powerful AI code from your server and run it directly in a user's web browser. That's a huge deal for creating super-fast, interactive experiences. And just look at their repo. They are all in on Rust. We're talking 98%. This isn't some Python library with a few Rust bits bolted on. This is a true native Rust tool through and through. Okay, so let's tie this all together. How do you decide if Rig is the right tool for your next project? It really boils down to what you're building. If you're a Rust developer, if you're building something where performance is absolutely critical, or if you're targeting WebAssembly for the browser, then yeah, Rig could be a fantastic fit. But on the flip side, if you're perfectly happy in the Python world, or if you absolutely need support for local models like Ollama right now, it might not be for you, at least not yet. And it's a young project, so you got to be ready for the API to change as it grows.
And that brings us to maybe the most important takeaway of all. The goal isn't to chase the newest, shiniest thing just because it's new. It's about using the right tool for the job. And if your job needs the power and performance of Rust, Rig is a seriously compelling choice.
So I'll leave you with this final thought to chew on. As AI gets woven deeper and deeper into our digital lives, are its foundations going to be built by those big, general-purpose Python giants? Or are we going to see a growing demand for specialized, high-performance tools like Rig, built for pure speed, safety, and efficiency? That's a question the entire industry is trying to figure out right now.